Hey everyone, this is going to be a quick video showing you how to do factor analysis in SPSS. So my professor actually sent me this data in R format, so I'm just going to show you quickly how to actually just switch something from another format to SPSS. Just give it a second because it's going to take a second to load. That's alright, we love you anyway, SPSS. So pretty much what you would do is go to open another file. Hopefully you have your data saved in some file. So initially it was in R, so I believe it was in, so I initially had it in this folder at .csv because that's what R uses. And so initially when you come on here, it's kind of going to assume that it's already in SPSS, so you have to go switch it to whatever data set you initially have it at, whatever that ending is, just check it out, and then you can just click on it, and that will convert it into SPSS for you. But I already did that, so I'm going to open it up here. So this here is now the same data set in SPSS. So to do a factor analysis, I definitely recommend taking a quick screenshot of this. My professor, Dr. Nabusi, put this together. Just definitely take a screenshot of that because that's going to be very helpful in any future factor analysis with SPSS. So I'm pretty much going to follow these instructions here. So we have this up, analyze. We want to go to dimension reduction, factor, which means factor analysis. So I'm going to move all of my variables over except for ID, because that ID is just a scale ordinal variable that just correlates with, it assigns each participant a number, so it really just goes from 1 to 600 or whatever the sample size is for this. Make sure to run your descriptive statistics so that you can look at your means and your sample size. So I'm also not going to move over gender because gender is typically just coded, it's a dummy variable, so it's typically 0 symbolizes male and 1 symbolizes female. So then if we go look at this, right? So we have all of our variables over here. We're going to go to, let's stay up. So we're going to go to descriptives, and we see here we want to do initial solution, and you want your coefficients. Then when we go to extraction, we want to do definitely based on engine value. And typically the standard for engine values is 1. Anything above, where did my little screenshot go? Oh, here it is. Oh my gosh, why am I dependent on this? Typically any engine value over 1 is considered good, useful. Anything below the engine value of 1, you typically might just want to not include in your analysis. So then we're going to extraction, and for extraction we want to do correlation matrix. We want to throw in a Scree plot based on engine value greater than 1 again. That's the standard. Rotation, Varimax rotation is good. There's different rotations that you use based on different data sets, so you might want to look into that, but Varimax is probably helpful for now. So we want to make sure, okay, that's good. Scores you can probably just leave alone. Options, you want to exclude cases pairwise, and you want to suppress small coefficients. That means that they won't pop up if they're really not related or significant. Turn it to absolute value below 30 because that's typically a safe standard to go with. So now we can click OK, and we're going to look at our output. So we have a nice correlation matrix here. You can see all of the correlations between your variables. That can be stressful though, so communalities. Communalities, long story short, you want it to be above 0.4. If it's a high communality, then you should be safe. So for example, if any of these went below at like 0.4, then I might just want to extract them from this factor analysis. You can rerun your factor analysis and just exclude those variables. Don't include these variables if they have, and that's what this is for. This is supposed to show you variables that aren't related to your study. So if it's below 0.4, then you rerun this without those variables included. Total variance explained. This is a quick way to look at how many factors you have. I'm not going to get into all of these, but you can see here we have 1, 2, 3, 4 different factors. Scree plot. Scree plot is going to show you how many factors are above that engine value of 1, because again, that 1 is the cutoff. And we can see here we have 1 factor, 2 factors, 3 factors, 4 factors above that cutoff of 1 right here. Then we have a component matrix, but this is a little bit confusing, so this is where Varimax rotation comes in. We can look at our rotated component matrix. This is beautiful. This makes things neat. You can clearly see which variables belong to which factors. You can see here these 5 are all highly correlated with factor 2. These 4 here are all highly correlated with factor 3. These 3 here are all highly correlated with factor 4. These 4 here are all highly correlated with factor 1. So I'm sure that you've noticed that some of these have 2 numbers. This is called cross-loading. These variables are cross-loaded. That means that the variable correlates with more than one factor, and that's normal. For example, for this one, and when I got this data set, there were no labels. It was just Y1 through Y16. I'm really just making up labels, so don't take any of this math as like fact. I was just assigning. You'll see how I assign labels. So back to cross-loadings. We see here that, for example, I have a hard time living. How about most activities are uninteresting or bore me? It's correlated with factor 1, but it's much. See, this is 0.347 and this is 0.723. So it's much higher correlated with factor 3. So I feel safe deciding that this variable belongs to factor 3. Same thing with this one. I have a hard time living in the moment. It's 0.368 for factor 1, and it's 0.623 for factor 3. So I feel comfortable saying that this variable here, correlates or belongs to factor 3. Same thing with this cross-loading here. My sleep schedule is consistent. It's much higher for factor 4, so I would put that in factor 4. We see a cross-loading here too. I'm often anxious. Much more highly correlated with factor 1. It's not bad that there are cross-loadings because, again, this data set was unlabeled. I'm not even really sure what these numbers reflect. I made it up, the variable names. But how I did that was I looked at, okay, so variable y1 through y5 here belong to variable 2. Let me show you actually how I decided this. Sorry, I'm not good at this, y'all. So what I started with, ignore all of these labels here. What I started with was just factor 1, and then I knew that factor y13, based off of this rotated matrix, I knew which variables correlated with which factor. So I really just started with factor 1, y13, y14, y15, y16, factor 2, y1, 2, 3, 4, 5. So then I decided this has got to measure some construct. Let's just say clinical depression. I got my undergrad in psychology, so this is one of the most easier things I could think of. So then factors are going to be kind of the bigger concepts, right? And the variables are going to measure that kind of bigger concept that the factor is. So I decided depressed mood, feelings of worthlessness, loss of interest, and insomnia and hypersomnia were big categories within trying to measure clinical depression. I then just went in and named the variables to have them be associated with the factor that they're measuring. So I really made these all up, but, use your imagination. These are the engine values that I have listed here, so you can see Y13 is most representative of factor 1, and over here you can see that Y1 was most representative of factor 2, and so on. So I was able to just kind of come up with some ideas here, and so then in this context it makes sense. Let's just use our imagination. So we see I have a hard time living in the moment correlates highly with factor 3, which is loss of interest, and it also correlates with factor 1, which is depressed mood. So that makes sense, right? I mean, you can have variables that make sense for 2 of your scales. Same thing with my sleep schedule is consistent. This one correlates with depressed mood, or, it being inconsistent. And it also correlates with insomnia and hypersomnia. Same thing with I'm often anxious. Of course, being anxious is going to correlate with depressed mood. And then it also correlates with factor 2, which is feelings of worthlessness. So maybe your anxiety, contributes to both your depressed mood and to feeling worthlessness. So you can see here how cross-loadings can definitely make sense, but just use, your educated guess to look at which factor the variable is more correlated with. And then from there, you can make a list, and then you can throw in some variable names, and you can really come up with a whole scale and construct that you're measuring. And it's really, use your imagination. It's fun. And then I guess the last thing I'll show you is that you can then, because of course when I got the data, it was just the variables were labeled Y1 through Y16. But the beautiful thing about SPSS is you can go into variable view and you can label all of your variables. So I did that based off of the ideas that I made over here for this stats project. So I brainstormed it over here and I brought it over here. And then you always want your variable name to be something succinct and easy, something that will remind you of what the label is, but you don't want it to be long like that, because then it will really complicate the tables that you have, and it won't be neat and it will be hard to read. So make sure to come up with variable names that are short and that other people, if they wanted to use your data, could also use. So that's pretty much it for factor analysis. If you have any questions, drop them in the comments, and I will definitely get back to you and do my best to help y'all. The biggest key to getting statistics is being confident about it. So just know that you got this and that you can do this. It's not beyond you. It's not beyond anyone. It just takes a little bit of time to figure it out. Good luck, everyone.